Hi there, I'm Chris Pinard and I'm a Phase 2 student here at the Ontario Veterinary College. I've always been passionate about parasites, and this summer I had the privilege of working with Dr. Andrew Peregrine and his lab on a project working with parasites in sheep. Sheep on Ontario pasture are commonly infected with mixed infections of 3 gastrointestinal nematodes. Of these 3, one is of particular importance, Homunculus contortus, due to its blood-feeding activity. This blood-feeding activity causes morbidity and mortality in sheep flocks, which is obviously of detriment to producers. Clinically, we see hemoncosis infections during the summer months. Unfortunately, recent work has shown that homunculus has shown a high level of resistance to common dewormers used by producers and clinicians alike. Therefore, there is an urgent need for a new drug that can act against homunculus. Another point about these parasites, about all 3 of these parasites, is that they produce identical looking eggs, as shown as the picture here. This makes them indistinguishable in the feces because they all are identical. Feces is collected from sheep and then mixed with water and placed in a strainer of appropriate size to isolate the eggs. This sample is then placed into a centrifuge tube and agitated with the lectin for about 1 hour. We are then able to observe the eggs under fluorescence microscopy and label them as either positive or negative for homunculus. So to determine the level of inter-observer agreement, we used a sample size of 21, and a Pearson correlation coefficient as well as a concordance correlation coefficient were both calculated to determine the level of inter-observer agreement for both blinded observers. Up here shows a clearly positive egg by the green wrapped around its membrane. Here is a negative egg, and here is another negative egg. Both clearly negative because of the yellow to brown color of their membrane in comparison to the positive for homunculus. So this is a homunculus egg, and these are not homunculus eggs. So again, this is just a zoomed in negative and a zoomed in positive as well. So our lab was able to establish the lectin method, meaning that it worked effectively. 98 to 99% of the eggs were readily distinguishable as either positive or negative for homunculus. Another thing to note is that this lectin method was extremely efficient in comparison to the culturing method, taking only a few hours to run multiple samples in comparison to culture, which took over 7 days to run just a few. This here is the inter-observer agreement for the lectin method. Here on the x-axis is the number of eggs counted by observer 1, and on the y-axis, the number of eggs counted by observer 2. The line in the center here is just the correlation between the two. So using the Pearson coefficient calculation, a Pearson coefficient of 91% was calculated. For the concordance correlation coefficient, a result of 89% was calculated, meaning that there was a high level of agreement between observers. The average difference between observers was only 3.1 eggs, meaning that both observers were effective in deciphering between positive and negative homunculus eggs, or eggs for homunculus. So overall, lectin proved to be an efficient and easy method to determine the level of homunculus in fecal samples of sheep. Ultimately, we hope that the Animal Health Lab at the Ontario Veterinary College will be able to use this both as a surveillance tool to determine the level of homunculus on pasture during the summer months, as well as a diagnostic tool for managing clinical cases. I'd like to thank Dr. Andrew Peregrine and his lab and everyone who helped out with the project this summer, as well as Elanco Animal Health, OMAFRA, and the Ontario Sheep Marketing Agency for all of their contributions towards this project. Thanks.